The term permutation comes from Latin, and is usually used in mathematics, more precisely combinatorics. Permutation means the rearrangement of objects in a certain order. If we look for instance at the numbers 1 to 4, you can rearrange the complete order, but it is also possible to switch only the 2 and 3. All possible permutations of a set can be calculated by using the factorial. For n objects, there are n factorial possible permutations. For our example, this means we have to determine 4 factorial. Using the formula, we calculate 4 times 3 times 2 times 1, which is 24. We can easily check that there are indeed 24 different possibilities to order the numbers from 1 to 4. The term substitution comes from mathematics, and describes the replacement of one term by another. Usually this should simplify the original term. In our example, we substitute 1 by 8. By an XOR operation we usually think of the addition of bits modulo 2. You might have also already heard of the XOR gate in some context. XOR stands for exclusive OR. If you want to add bits by an XOR operation in practice, you usually do this for each individual number of the bits. This means, adding the respective numbers of the bits using common addition, and then you check whether the individual numbers are even or odd. Is the number even, then you note down a 0. If the number is odd, then you note down a 1. We will illustrate this with an example. First of all, we add the individual numbers of the bits up in the way we are used to. And then we check whether the number is even or odd, resulting in a 0 or a 1. If you want to look at a more mathematical explanation, click on the button on the right. Also note, that the usual symbol for this operation is a plus in a circle, meaning the calculation should be actually written down as shown. This operation can also be defined by making use of the definition of modulo calculation. The end result is the same one, but the definition is more mathematical. If you want to add 2 bits modulo 2, this means you add those 2 bits, then divide the result by 2 and afterwards focus on the remainder of the division. Remainder 0 means that the result is also 0. Remainder 1 means the result equals 1. We will illustrate this with an example. First of all, we add the bits up in the way we are used to. The result, which consists of 0s, 1s and 2s, is now divided by 2. Now, we are only interested in the remainder of the division, which is our actual result.